This presentation is part of the TI-Nfocus AP Calculus video series. In this video, I'll discuss the scoring guidelines for the 2019 AP Calculus exam, free response question AB3 BC3. My name is Steve Kokoska. I'm a professor at Bloomsburg University in Pennsylvania, and I'm a former AP Calculus chief reader. Here is an outline of the information presented in this video. I'll start by reviewing the free response question, and then the scoring guidelines used at the AP Calculus reading in Kansas City. I'll present a brief general summary for student performance on this question. Then I'll consider more detailed interpretations of the scoring guidelines and how these guidelines were applied in certain situations. I'll consider some common student errors where it's relevant, and where appropriate, I will present some specific scoring examples. This problem involved the graph of a continuous function f, defined on the closed interval -6 to 5. Part of the graph of f, given in the figure, consists of two line segments and a quarter circle centered at the point 5, 3. In addition to the points marked on the graph of f, the point 3 minus the square root of 5, is also on the graph of f. In Part A, we're given the value of a definite integral and asked to find the value of a related definite integral. Note that the student is reminded to show the work that leads to the answer. In Part B, we're asked to evaluate a definite integral involving the derivative of the function f. In Part C, we're given a new function g, defined in terms of a definite integral. And we need to find the absolute maximum value of this function over the interval -2 to 5. And in Part D, we need to evaluate a limit. Part A was worth 3 points. 1 point for using an appropriate property of integrals to rewrite the desired definite integral, 1 point for evaluating the definite integral -2 to 5 of f of x dx, and 1 point for the final answer. Part B was worth 2 points. 1 point for using the fundamental theorem of calculus associated with the definite integral of f prime of x, and 1 point for the final answer. Note that there are two very similar solutions to Part B presented in the scoring guidelines. The first solution presents two separate definite integrals without the symbolic antiderivatives. The second solution presents the antiderivatives and then directly to the evaluation. These were the two most common solution methods presented by students. Part C was worth 3 points. 1 point for connecting g prime with the function f, 1 point for identifying x equal -1 as a candidate for the location of the absolute maximum value, and 1 point for the answer, the absolute maximum value over the interval, with appropriate justification. And finally, Part D was worth 1 point, simply for the answer. Here are some general comments about student performance on this question. In Part A, most students showed some understanding of the property of definite integrals needed to solve this problem. And most also showed some evidence that the definite integral could be evaluated using area. So, conceptually, there were some good presentations. However, some students had trouble finding the definite integral from 2 to 5 of f of x dx. Now, this integral could be evaluated by finding the area of a square minus the area of a quarter circle. And there were also some students who actually tried to find an analytic expression for the function f, a piecewise defined function. This was a possible solution method, long, but certainly possible. And in Part B, many students had trouble applying the fundamental theorem of calculus to this definite integral. A common error involved an antiderivative of f prime of x squared, or f of x squared. Some students didn't know how to handle the coefficient 2 or the constant 4 in the integrand. And, unfortunately, there were several non-calculus errors in this problem, algebraic or arithmetic mistakes. In Part C, there were a number of responses with a correct answer and a complete justification. However, several students presented vague or incomplete justifications. Remember that clear, concise communication of results is very important. Some students presented an area argument, which was possible and even intuitive, but they didn't present sufficient justification for their answer. Many students showed evidence of the fundamental theorem of calculus, but there were some common misconceptions. For example, some students wrote g prime of x is equal to f of x minus f of minus 2, and others wrote g prime of x is equal to f of x dx. Many students presented a local rather than a global argument, and some students didn't address the critical point x equal 1/2. In Part D, most students correctly attempted to find this limit by substitution. However, some students incorrectly tried to apply L'Hopital's rule. Some students presented non-calculus errors. And there were some students who evaluated the arctan of 1 incorrectly. Remember that students don't need to evaluate a final numerical expression. In Part A, the first point was for using an appropriate property of integrals to split the given definite integral into two parts. And this was a conceptual point. We need to see evidence of the correct property of integrals applied to our problem. Here are some examples that earned the first point. All demonstrate sufficient evidence of the appropriate property of integrals. The notation in examples 5 and 6 is lacking. In example 5, each definite integral is missing the differential dx. And example 6 is pretty minimal, but still accepted as evidence of the appropriate property of integrals. The student did not have to start this problem by explicitly applying the property of integrals. That'd be nice, but the first point in Part A can be earned if it is embedded in the final answer. And here are two examples. Each of these earns all 3 points in Part A. Many students started this problem by writing an expression of the form 7 minus a, where a is an incorrect value of the definite integral minus 2 to 5 of f of x dx. If the student sufficiently conveyed they were evaluating this definite integral, then they earned the first point. They did not earn the second point, but they were eligible for the third. Now, in order to be eligible, they needed to present a reasonable attempt at evaluating the definite integral using area. We need to be convinced that they're working with our area. The second point in Part A was earned for the correct value of this definite integral, and for the correct value only. This value does not need to be simplified, but any simplification must be done correctly. Here are two common expressions for the definite integral. Now, we expect to see some work leading to this result. And in this case, we were willing to look on or near the graph given in this problem. And finally, the third point in Part A was for the answer. Now, this requires the student to connect the property of integrals and the value of the definite integral from minus 2 to 5 of f of x dx. This point is earned for our answer, or an answer that is consistent with an eligible declared value of the definite integral from minus 2 to 5 of f of x dx. Now again, an eligible declared value must convey that the student is working with our area, and they cannot be adding the area of a quarter circle in their declared value. There were some other issues in this part, and I just want you to know that there were guidelines for scoring these presentations. For example, some students presented reversals in the bounds of the definite integrals. There were linkage errors. These are unequal expressions connected with an equal sign. And even though this was a non-calculator problem, some students presented decimals. And some students attempted to solve this problem by first trying to find an analytic piecewise expression for the function f. In Part B, the first point was for showing knowledge of the fundamental theorem of calculus. And in order to earn this point, the student needs to show two items: the antiderivative of f prime of x and the use of the limits of integration. Both of these must be present for the student to earn this point. But the work may or may not include integral notation. Here are some examples. In example 1, the student hasn't used the limits of integration yet. They're still eligible for point 1 if they show more work, and of course they're eligible for the second point also, with more work. In example 2, the student earns the first point and is eligible for the second. In example 3, the student also earns the first point and is eligible for the second. Note that there's no integral notation presented. So, for the first point, we're really focusing on the definite integral from 3 to 5 of f prime of x dx. Errors in other parts of the integration are considered in the second point. Therefore, each of these responses earns the first point, but not the second. The second point in Part B was for the answer. This was earned for our answer only. And remember that no simplification is needed, but any simplification that is presented must be done correctly. It is possible for the student to earn both points in Part B by writing one minimal expression. Remember that f of 5 is easy to read from the graph, and f of 3 was given in the statement of the problem. In these minimal responses, we must be convinced that the student has correctly handled the integral of f prime of x and the limits of integration. In example 1, we're convinced the student handled the integral of f prime of x dx and the limits of integration. But they still need to evaluate f of 3 to earn the answer point. So this response earns the first point, and the student could go on to earn the second point. In example 2, the student earns both points. In example 3, there isn't enough evidence for the first point, but we will award the answer point. In example 4, there isn't enough evidence for the first point, and they have not earned the answer point. And in example 5, we're convinced the student handled the integral of f prime of x dx and the limits of integration. But there is a parenthesis error here, so this response alone earns 1 0. In Part C, the first point was for explicitly making the connection g prime of x equals f of x. And here are the two most common ways that students conveyed this equality. In example 3, this is simply not the connection we need to see. There is no function capital F in this problem, so we can't infer its definition. In example 4, the student cannot leave x prime or dx in their connection point. However, they could go further and indicate that this value is 1. In example 5, under the pressure of a high-stakes exam, we tend to forgive certain slips of the pen. And this point could be earned with a statement in words. For example, the student might write, the given graph is the derivative of g, or simply, the graph is the derivative of g. The second point is earned for the identification of x equal minus 1 as a candidate. This point is independent of the first point, so a student could earn a 0, 1, 0. This value can be identified in many ways, for example as a candidate in a table. Or x equal minus 1 may be embedded in a paragraph response. This point can be earned regardless of how many or how few additional candidates are presented. And there is no reasoning necessary here. Just identify the value. The third point in Part C is for the answer with justification. And there was an eligibility criteria here. The student must earn the first 2 points. And the response must declare as an answer the maximum value, 11 minus 9 pi divided by 4. A complete justification only needs values for g of minus 1 and g of 5. But there must be a reason for excluding g of a half. The justification doesn't need to present a reason for excluding g of minus 2. It's pretty easy to see that this value is 0. Now remember that students calculated g of 5 in Part A. So we will read with imported values that are greater than a half. And just for emphasis, the table, as presented in the scoring guidelines, is the justification. But all values presented by the student must be correct. And any extra values must also be correct in order to earn the third point. Some students attempted an alternate solution by using accumulated area to justify the maximum value of the function. This justification must include specific information that connects the function g to the given graph of f. In Part D, the point is earned for the answer, and this is earned for our answer only. The answer doesn't need to be simplified, but if it is, then it must be correct. And arctan of 1 does not need to be evaluated. It can be part of a final numerical answer. Responses here do not need limit notation, and we will accept hanging limit notation as an indication of the value of the limit. But we will not accept this response in item 5. This is a limit expression and an indication that the student has not yet evaluated the limit. We will accept the response in item 6. At the AP Calculus reading, an actual briefing for the scoring of a free response question usually takes approximately 75 minutes. There is also time allotted in the reading rooms for discussion before the actual scoring begins. However, I hope this summary video gives you a good idea of how this question was scored. And just a reminder, there are lots of valuable resources on the TI website. There is material there involving technology and calculus, classroom activities, and lots of calculator tips and tricks for test success.